Okay, so our first step, we want to make sure the coefficients on one variable are the same, and step 2 is add or subtract equations to eliminate one variable and solve for the other. We always want to choose the variable that is raised to the first degree. In other words, here we have y to the power of 1 and y to the power of 1, so we want to choose that. If we try doing this with our squared or our second degree or more, it's going to get tricky. So the next we want to get our coefficients the same for those y's. We see the first one we have a -1, the second one a -2. So if we multiply our first equation by 2, we will bring that to be the same as our other one. So let's go ahead, I'm just going to label these our equations 1 and 2. So I'm going to multiply equation 1 by 2. So bring that 2 in front. 3x squared minus x minus y minus 2 equals 0. Multiplying that 2 through, we get 6x squared minus 2x minus 2y minus 4 equals 0. Okay, we did multiply that 0 by 2 as well. 0 times 2 is going to give us 0. Next then, we want to add or subtract equations to eliminate one variable. So how do I get rid of my y? Well, we, in this case, are going to subtract a -2 minus a -2 is going to give me 0. So we take our new equation here, and we subtract equation 2 from it. So I'm going to go minus 12x squared plus 8x minus 2y. Okay, it's nice when our variables line up nicely. So this last one, rather than leave the 8 on the other side, I'm going to subtract 8 from both sides, giving us minus 8 on the left side equals 0. You can go ahead and do that then. So 6x squared minus 12x squared is -6x squared. -2 minus 8 is -10x. These are going to cancel. I could put in my plus 0y if I wanted, but that doesn't really mean anything, so we can get rid of that. And then -4 minus a -8. I want to think add the opposite, so -4 plus 8 is plus 4 equals 0. Now that we no longer have a y in the equation, we can go ahead and factor that to solve for x. So similar to that last question, we're going to want to solve this by grouping. I'm going to bring that 0 to the other side, and the 6x squared plus 10x minus 4. Notice I just switched the sign by switching the sides. Basically, I multiplied both sides by a -1. Now, let's take our 6x squared. Let's split up that 10x into 12x and -2x minus 4. Now we can collect like terms in our two sets. So we take a 6x out of these first two to get x plus 2. And we take out a -2 out of that second set to get x plus 2. Again, we see that we have our x plus 2 and our x plus 2, allowing us to combine 6x minus 2 as they have a like factor of x plus 2. This means that we have our roots at x equals 2 over 6, which is equal to 1 over 3. And we also have one at x equals -2. Next then, similar to what we did for substitution, is plugging these variables into our other equations to find what y is equal to. So I'm going to go ahead and do that. We take 3x squared minus x minus y minus 2 equals 0. Wherever I see an x, I plug in 1/3. We end up working out that y equals -2. So one solution for this system is 1/3 -2. And then again, we have to do our other root as well. 3x squared minus x minus y minus 2 equals 0. Again, that first equation. Plug in the -2 wherever we had our x. So we end up with 12 plus 2 minus 2 equals y. Again, bringing that y over by adding, leaving us with 12 equals y. This giving our other solution of negative 2, 12. So we have our two solutions for this equation then. Okay, let's move on to the next one. Okay, so why don't you try these next two questions on your own, and then when you're ready, hit play, and I will show you the solution and make little notes for things that you may have noticed that made this question a little bit more difficult. Alright, so if you worked it out correctly, this is what you should have had. Our solutions at negative 5 over 4, 55 over 8, and 1, 8. So here we multiplied our first equation by 2 in order to get both equations having 2y. Then because one was a negative, one was a positive, we ended up adding them together to cancel out those y's, leaving us just with x's. Again, factoring by grouping and working our way through. Then with the next question, we saw that our y's were already the same coefficient, so we could just subtract right away, end up with our negative 3x squared minus 5x plus 0y. Okay, sometimes it's nice to just keep that in there so you know you didn't forget anything. Minus 2 equals negative 4. And again, factoring by grouping, working our way down, getting our roots, and then plugging these in to get our final solutions. So let's go ahead and move on to our word problem then. Here we have two numbers are related in this way. 2 times the first number, subtract 5, is equal to the second number. And the sum of the second number and the square of the first number is 115. We want to A, collect a system of equation to represent this relationship, and B, solve the system to determine the numbers. It's very similar to what we had done with solving graphically, setting everything up, just this time we are solving it algebraically. So why don't you go ahead, pause it, set up your let statement, see if you can get your system of equations together, and then we will work through this algebraically together. Alright, so we could have done this numerous ways. I chose to let x equal our first number and let y equal second number. Okay, these don't have to be anything fancy, just so we know what is what. Okay, then we have 2 times the first number, subtract 5 is equal to second number. Okay, so 2 times, so 2x, our first number, minus 5, subtract 5, is equal to our second number, which was y. Then we have the sum of the second number, so we know we're going to be adding, sum of the second number, which is y, and the square of the first number, so x, first number squared, is going to equal 115. So there's our system of equations. At this point, we can go ahead and solve it. I'm going to choose to solve this one using substitution. I like that method better, especially considering our y is already on its own. So I'm going to plug that into our other equation. Y plus x squared equals 115. Wherever I see the y, I plug in my 2x minus 5 plus x squared equals 115. We end up with x squared plus 2x. Bring this 115 over by subtracting it, so minus 120. Notice how I'm already setting it up in our x squared plus x plus our lone coefficient. Just speeds things up a little bit when we need to factor. Here again, we're looking to multiply to 120, add to 2, then multiplying, giving us a negative. So let's go with x plus 12, x minus 10 equals 0, x equals negative 12, x equals 10. this point, we just need to plug in these to our equations to find what our y is equal to. So we get 2x minus 5 equals y. Plug in a negative 12. So we get negative 29 equals y. And then our other one, we plug in our x equal to 10. So our solutions then negative 12, negative 29, and 10, 15. Okay, so again, we should be able to double check that these work. So 2 times the first number, subtract 5. So if I take 12 times 2, that gives me negative 24. If I subtract another 5, that equals negative 29, so that works. And then the second one, 10 times 2 is 20, subtract 5, that gives me 15. All right, so that first rule is good. Then the sum of the second number and the square of the first number is 115. So if I take negative 12 squared, I get 144. I add that to negative 29 and I get 115. And then if I take 10 squared and I add that to 15, I also get 115. So that rule works. So we know that we are good with these solutions. All right, so you should be good to go on to the assignment then. That's page 451, questions 1 through 4, 6, 8, 9, 10, 14. Some good focus questions there are 3, 4, 8, and 9. But again, these are the minimum amount I would like you to see before moving on to your quiz. I would encourage you to try a few more of the questions, especially those word problems, trying to set up your let statements and then going through the process either using elimination or substitution. Good luck, and as always, feel free to ask me questions that you may have or post in our comments section on the website and see if your classmates can help you out.